Welcome everyone to this webinar, whether you're watching live or the recorded version of this event. I'm Kamal Haddad. I'm a research engineer with Calumet Energy Technology Center with Natural Resources Canada. This webinar is organized by IBPSA-USA Building Data Exchange Committee, and the main goal of this committee is to facilitate the exchange of information between building performance simulation software tools through the development of standard data models and schemas. So today's webinar deals with automating the transfer of data between building information modeling and building energy modeling tools. And it's titled toward building performance analysis with BIM plus BEM. In this webinar, we will explore a streamlined workflow from different model authoring platforms into cove.tool. Participants will be able to see how having a single source of information is advantageous to achieving holistic data-driven decision-making for high-performance building design. Our first speaker is Patricia Kusumadjaja, who is a virtual design construction director at cove.tool. She has over 9 years of experience of working in the AEC industry, namely in architecture cost estimating, virtual design and construction, and project delivery. Patricia earned a Bachelor of Architecture in 2015 from Kennesaw State University, and her CEP Certified Estimating Professional from AACE in 2020. She strives to make a difference in the way owners, construction, and architecture professionals view high-performance design and cost, with the hope that sustainability and environmental consciousness become a non-negotiable priority in all future building design and construction. And our second speaker is Udiksha Kapini. Udiksha is a BIM specialist with the research tool at with the research team at cove.tool. She has a Master of Science in Architectural Technologies from Georgia Tech. She specializes in integrating building information systems and data through a multidisciplinary understanding of the built environment and architectural technologies. Her work at cove.tool explores the collaboration of building performance and the rapidly growing technological trends in the AEC industry with BIM capabilities. She believes in the true transformation of information from design to construction through automating building intelligence. We also have with us from cove.tool, Patrick Pease, who will be monitoring the chat and possibly answering questions during the presentations. And at the end, we'll have about 10 to 15 minutes for questions after the two presentations we have. And toward the end, you can also raise your hand and we will allow you to speak live if you choose to do so. So Patricia, over to you.
Okay, sounds great. Thank you, Kamal, for that lovely introduction. So I'm going to go ahead and share my screen. Okay, and you should all be seeing my screen. Let me know if you are not. Okay, so yeah, good afternoon, everybody. Thank you for having us here today and allowing us to have the space to talk about building performance analysis with BIM and BEM. So as Kamal mentioned, my name is Patricia Kusumadjaja. I'm the VDC director here at cove.tool. And as he mentioned, I started my career about 9 years ago as a BIM specialist at a project delivery firm. Later, I got into cost estimating and I specialized in integrated project delivery. And presenting with me today is Udiksha, our BIM specialist. And Udiksha, do you want to say just a few things about yourself?
Yeah, good afternoon, everyone. I'm Udiksha, and as Patricia mentioned, I am a BIM specialist here at cove.tool. And my work here is, of course, integrating better workflows for achieving exports from BIM softwares into our building performance platform.
Awesome. Thank you, Udiksha. So we're going to segue first with what we're kind of all about here at cove.tool. So our core mission is to fight climate change through responsible building design, and BIM technology is really a key component in this effort. So in our industry, we know that buildings are responsible for at least 40% of the carbon emission that is causing climate change. And the good news is now that there's so much awareness around climate change that consumers are beginning to demand more sustainability. So it's really in the best interest of owners to deliver on that. So we're seeing that more owners are wanting to invest in sustainable buildings. And in addition to that, and this one really impacts all of us in in our day-to-day jobs as building professionals, is that governing entities are starting to impose stricter regulations to require that buildings meet net zero by 2030. And however, what that's done is that it's increased the cost of the design and construction efforts. Oh, excuse me. So how do we deal with this increasing effort that's now demanded from design teams? What can we do as building performance professionals to make sure that we're still able to deliver high performance projects despite the rising construction cost? So with this today, we're going to show you how early integration of BIM and BEM can lead to data-driven design and can help you find the balance between sustainability and cost. And we're also going to share an overview of best practices based on our cove.tool BIM guide that Udiksha and I recently worked on, which is not yet published, but will be soon. So you're getting sort of an exclusive look. And finally, we're going to look at different workflows of how cove.tool works with different 3D modeling platforms. So in our research, we found that generally speaking, these are some of the workflow related issues that, excuse me, that many professionals are struggling with. In a project, there are so many experts of varying disciplines involved, but they work largely in silos, which a lot of the times can lead to communication problems that leads then to budgetary issues. And on top of that, as we've already mentioned earlier, there is this additional step now of making sure that we are in compliance, which can take more time and can cost us more money. So based on these three findings, we'd like to float this survey question to you all. Which of these three issues do you feel is one that you have the most struggle with currently? So if we can float that survey question now, and we'll give you all about 30 seconds to just pick one. Okay, I think that's about 30 seconds. Looks like we're still getting a few more results. So here are some of the results. So about 67% of us are, probably a little frustrated with the way that we're working. And to be honest, I wasn't expecting it to be on that side, but I'm not super surprised. So with that, let me stop sharing this poll. Okay. And so with that, it kind of segues in really well, luckily, to this particular slide. And this is a quote that has sort of stayed with me for the last 10 years that I've been in this profession. And it's something that one of my former bosses have said. There is a profit being made with inefficiencies. And that is such an unfortunate thing, but it's really true. And I think a lot of us are aware that our industry can be really relaxed when it comes to technological and workflow advancement. And we see this in the results, right? So based on the survey alone, 67% of you are experiencing this sort of struggle with workflows and, this sort of siloed ways that we're working. And on top of that, nearly 80% of projects are over budget. We're losing money, we're working more, and the saddest part of it is that our project's performances are not necessarily getting better. So we have here in this graph a typical design cycle rate, everything from pre-design to construction, admin to operations. So, and as many of you know, right at this early stages of design, in the pre-design schematic and like early DD, we have this high ability to impact the project cost and the project performance, because nothing at this point is really set in stone. So changing strategies, thinking of new ways or introducing new technologies is going to be a little bit easier at this stage. And the cost of those changes are going to be relatively low. But despite that being the case, what we're seeing in traditional workflows is that performance modeling happens later on in late DD through CDs. And it doesn't really make sense to us because that is literally the most expensive pace for us to make these changes, which is why integrating BIM and early energy analysis, which is what we're pushing for here at cove.tool, it just makes sense. So that way, by the time you make it to the CD stage, we're already in a really good place. We know what our performance is looking like, and our building is already optimized. So for those of you who are not as familiar with cove.tool, just a brief background. cove.tool is an automated design platform for intelligent building performance. And our goal is to make it easier for design professionals to build smarter, to work in a more holistic environment, and really in a shorter amount of time. Our goal is to help you win more work and reduce the amount of time that we're spending in design cycles doing revisions. And the way that we're doing this is we're trying to streamline and trying to automate the workflow. As we kind of mentioned earlier, in a traditional workflow, the decisions that we're making are happening in silos. As you can see in the sort of graph at the top, there are the different stages of design. We're making decisions at different times and sometimes without really complete information from other disciplines. So we asked the question, what if there was a way, and there is a way, to see what exactly is happening with our design in its entirety so that we can collaborate with other disciplines in a much easier fashion so that we make those decisions together. And that is what is essentially happening in the optimized workflow at the bottom of the slide. In the optimized approach, we have all of these elements, and it's a much more interwoven, holistic, path of working. We are using a machine learning engine, and that allows us to ensure that every alternative product and design strategy is explored, and that the lowest cost and energy combinations or bundles are figured out. And this process to uncover this, holistic optimal bundle is one of the most widely leveraged studies that we have in our platform. And so in addition to, providing the visualization and understanding of building design performance, we can also make decisions at an early stage that is validated by data with cove.tool. And the end goal of what you're seeing here, which is our optimization tool, is to find that combination of options that will perform the baseline model. So we're essentially asking the question, how do we make our buildings perform better? And this is going to provide us with several paths forwards to make this building design better. But now what we're doing is we're weighing all of the different options. We're not really making those decisions in silos anymore. So before we jump into the cove.tool platform itself, in the process, we are starting out with a building information model or a building energy model. So let's talk a little bit about how we're defining these two, BIM and BEM, and the ideal workflow for the two processes and the steps of the model preparation. So in our cove.tool BIM guide, we start with the 3 definitions of BIM defined by the National BIM standard. The first definition is BIM as Building Information Modeling. As defined in the slide, it's the process of creating and utilizing data for the purpose of designing, constructing, and operating a building during its life cycle. The second definition, which is building information management, is the organizational process of the modeling of the first definition, and it involves information sharing, coordination throughout with the different disciplines throughout the project's life cycle. And the last definition is building information model, which is the outcome of the first 2 definitions. It's the digital representation of the building design and functionality. And in this context, BIM becomes the sole source of information for a building, and it serves as that tangible resource for decision-making during the project's life cycle. And on the flip side, let's talk about building energy model and modeling. An energy model essentially is the calculation of heat flow in and out of a building. It measures the amount of energy that has to be expended in order to maintain the ideal level of indoor comfort. And so with cove.tool, we want to make sure that each building that will be constructed is getting that energy modeling treatment. So we're making the process of creating the energy model a little bit easier through automation. So if you look at this slide, we have this input section, which is where we take from the building information model that the design team has spent a lot of time on. We take that geometry, the building orientation, as well as information on the building functionalities and the assemblies. We layer that with additional data from MEP disciplines and other energy conservation measures from engineers and consultants. With all of this information together in cove.tool, we can generate a building energy model fairly swiftly to use for performance simulation and analysis. Then we integrate some of the baseline assumptions based on the energy code selection that is pre-built into cove.tool, other calibration and energy standards such as ASHRAE, as well as industry standard best practices to run the energy performance simulation. So the output, or the results that we get, as you see here, is the energy use intensity and the associated breakdown of that energy use intensity and the operational or the utility cost. And so this is how we arrive at performance analysis, basically taking it from, starting out with that building information model, generating a building energy model to do performance analysis. And performance modeling essentially is an approach to design that uses the 3D computer models that we're working on to iteratively test, analyze, and improve upon our design. And of course, the disclaimer here is that's important to keep in mind is that not all models are going to be 110% accurate because models are approximations of reality. But that still, it still is a good point to remember that understanding how each of the decisions that we make along the design process really makes a big difference in the overall performance of the design, particularly when we're starting to do this exercise at the very early stage and continuously throughout the different stages of design. And this process, again, when it's integrated earlier, it allows for real-time, multiple option, data-driven decision-making. And so now that we have a good understanding on how we can use BIM to generate BEM to do performance analysis, starting at the early stages of a project, we can dive in a little deeper into what this workflow looks like from a practice standpoint. We want to look at the collaboration and the early integration, what that entails, and what are the interoperability and the geometry best practices that we recommend our users to adopt. So with this, I will turn this over to Udiksha.
Great, thank you, Patricia. That was great. to lay down the foundations of BIM and BEM. But now let's take a look into the ideal workflow that we recommend. So let's start off with collaboration. So we did stress on how important it is to collaborate and and include findings from all the stakeholders in your project. And that's something that we also would like to adopt within our platform. So we always believe in collaborating and making sure everyone involved in the project is at the same page. So a successful collaboration on any project involves the design team, the performance consultant, cost estimators. This is how you are able to achieve your goals without having to lose on the translation of data when you are coordinating. So yeah, this is something that we did also bring up earlier in the presentation, which is the McLeamy's curve. Here, we like to stress on what kind of deliverables are expected in the early design phase versus the later design phases like construction documentation. And as you can see, the amount of deliverables just keeps on increasing. The amount of effort and time you spend on your construction documentation phase versus your pre-design phase is a lot more. The amount of effort increases, which is why we stress on implementing these energy conservation measures or any sort of design iterations at the early stages, which is in your pre-design and schematic design phase. And that's where you will adopt cove.tool to help you make those design decisions to achieve more data-driven results. Yeah, so let's now go into the interoperability section. So ideally, as we know, interoperability is a key factor in order to maintain the amount of data that's being translated from your very detailed BIM model to the energy model. And it is a key factor and a common challenge we are seeing in a lot of software tools out there. So, which is why we are able to bridge that gap by providing, plugins for geometry modeling tools, the most commonly used modeling platforms. We are providing plugins in order to bridge that gap between the translation of data from your information model, the building information model, and into your energy analysis on cove.tool. So the ideal workflow would be to set up that model that has all your geometry details, and then you have your building energy model that has all your detailed inputs on your loads, on your mechanical strategies, and we have dedicated export options that aid for that collaborative interoperability so you are able to continue that detailed level energy analysis. And whether you do energy modeling in-house or whether you hire consultants, it is a time-consuming process when you are switching between different platforms. That is why cove.tool is able to provide a wide list of plugins that can export your geometry at different stages of your project. So you may have a project that's in your early design phase modeled in SketchUp, for example, or Rhino, but you also have a more detailed model that's been developed in Revit. So these plugins are able to help you export your geometry and perform energy analysis through our cove.tool platform. So we want to integrate all the geometry, all the most commonly used modeling platforms, and also include integrating other sources of platforms that aid in this collaborative process like TestFit and so on. So now that we have our geometry into the project, one thing we also want to make sure is trying to understand what kind of spaces are going to overall affect your energy results. So the first rule we need, or the first aspect you would take a look at in your project is the thermal envelope. So we need geometry from your thermal envelope in order to run our analysis, which is the daylight model and the energy model. And within the thermal envelope, it is crucial to have the right categories or the right building categories assigned in order for us to perform that energy analysis. So when you take a look at all the categories within that thermal envelope, we have 11 of them, out of which 5 are required and 6 are optional. And these categories are basically set up based on how they perform and how the thermal resistance is on the different categories. So the 5 required ones we have are the exterior building, the exterior walls, the floor slabs, the roof slab, the glazing, of course, and the building height. So with just these 5 minimum inputs, we are still able to run a energy and daylight model. But of course, you would also want to bring in optional categories that add to your design strategies, that add to shading benefit, like shading devices, overhangs, fins, interior walls for daylight, skylights to bring in more daylight, and so on. So this is how our geometry is categorized essentially uh, through any of our plugins. And now that we have all your geometry aspects figured out, let's go into how to prep your model to make it ready for that Cove tool integration. So we're going to take a look at some examples of messy models that can affect your overall export. We're also going to take a look at what affects your model performance, and that's in general, for a Revit application or a Revit project. We're also going to take a look at the cleanup steps, if there needs to be any, and of course, best practices to achieve faster exports. So for messy models, here are a few examples of something that can be too detailed. And this depends on your BIM authoring model, of course, the amount of data that's going in, how the structure or the data schema is set up for that software. And we want to limit the amount of data that's going in so that we are only bringing in necessary details for that energy model. So within your Revit model, you may come across 2 scenarios that we call a messy situation and a problematic situation. A messy situation can be dealt with. They can be workarounds, can be manipulated, can be simplified. Whereas a problematic situation is wherein you would need to redo a lot of things, remodel, and that would actually cost you a lot of time, and that is not the right approach. And to deal with such problematic situations, you would definitely need to have some best practices set up for your BIM models and also your energy models that are being exported. And here are a few examples of super detailed object types that can lead to problematic scenarios when you are exporting. So if you do use super detailed families or Revit families that have been provided by the manufacturers or just downloaded online, they tend to be over detailed, that have way too many elements. Again, these are not essential for your overall energy results. They're going to add a lot more detail and slow down that export. Even examples of reveals, sweeps, these are just really common examples. You may have excessive view templates, and in general, these are problematic BIM practices and not necessarily for energy models. And because of these excessive objects, your model can get heavy, it can get slower, it can entirely crash, of course, and we want to avoid such scenarios, especially when you want to translate data more effectively. And to help you in that BIM best practice, here are some things that you can definitely review and make sure to keep in tabs when you are developing a Revit model or any other BIM model to start with. So early adoption is always, of course, beneficial. So when you are creating new families, limit in place families that you are using. Try to keep them at a minimum, especially if they are repetitive and there are not many changes in the parameters. Of course, model groups and detail groups, too many model groups can definitely slow down your entire model performance. If you have way too many warnings, that also, of course, can lead to more problems and performance in that Revit export. So try and purge unnecessary elements as well when you start to see that your model is going to get a lot more information. And once you have your model set up and you have it ready for the Cove tool export, in this example, what we're doing is just showing you that export cleanup for a typical Revit model. All we're doing here in this particular slide is showing you a before and after essentially of what it looked like when you do create your views, which is an automated process already. The plugin is able to identify properties from your object types. But if there does need to be some sort of cleanup, it is a quick and easy step to hide and unhide objects. And I will also be demonstrating a Revit export shortly. And while we're still on the topic of best practices, Revit families tend to get super detailed. So here are some few best practice tips to make sure that you're not using really heavy, over detailed family types. And a good example of a Revit family is if it is under 2 MB. Anything over that would mean it has unnecessary instance parameters, or if you have multiple families within itself, that can also lead to slower performance of your Revit model. But if you are building multiple window families or any family in general, make sure you are building them to assign subcategories within them and laying out object types and its functionality. And of course, any unnecessary details or overlapping surfaces in general will affect your model and also the export to energy analysis. So yeah, so now that we've got all the details on the model preparation, what I'm going to do now is share my screen and show you the export from 3 of our plugins, which is the Revit plugin, the SketchUp plugin, and the Rhino and Grasshopper plugin. So I'm going to start sharing my screen in just a bit. Okay. And you can give me a thumbs up if that's visible. Okay, great. So let's take a look at our Cove tool application to begin with. So here I have an example project that I'm going to be exporting to. And like we did point out earlier, we need inputs. And those inputs here are a project name, the building type, the project location that also chooses the weather file for us to run our simulations, and of course the energy code. So here is the input section of your project. We're going to now also bring in the geometry from Revit. So once we have these 2 inputs, which is your project details and your geometry, we're then going to show you everything else that we're simulating in terms of daylight analysis, energy results, and so on. So I'm going to now hop back into Revit and basically export this sample project. So when you do have when you have downloaded the Cove tool plugin, the workflow for exporting essentially is to update your login, select the project. So we're basically just going to look for that project that we just exported to. Once we have the project selected, we're going to choose the origin point, which basically is used to place your building on that location that you gave us. So I'm going to click on submit. And now that we have the project selected, we can go into the plugin and go into step 3. So we just finished the first 2 steps, which is to log in and select the project. We're going to now go to 3, which is to create your Cove tool views. So these Cove tool views are going to be generated under the 3D browser here, project browser here, and you have these 11 different 3D views that have been generated for the project. And these views are basically filtering based on object properties, what is relevant for each of them. For example, all your exterior walls are now filtered from this overall 3D view into this view. And they're basically on visibility. They will, whatever is visible in these 11 3D views is what's going to get exported. And like I said, these are based on properties of the object type. So in case of a wall, if you go into the properties of that wall type, we use this function parameter to find object properties and classify them into these Cove tool views. So I just gave you an example for the wall type. Since it was set at exterior, walls of this condition are going to be filtered in here. And we also have an interior wall view. And for that, if the walls were set with a function parameter as interior, it's going to all go into the Cove tool interior wall view. We also have a below grade wall view, which is going to look for either foundation or retaining walls. So that's basically how our plugin works. It's on visibility and object properties that filter in all these Revit families or these objects that are appropriately classified. So here, this is the Cove tool floor view. which has all the floor objects. We also have the cove tool roof view, which has all the roof families or all the objects that were modeled as roof families, and so on. These are the 11 views. And like we did mention earlier, we have 5 required categories, which means that we do need geometry that's coming in from your exterior wall view, your floor view, your roof view, and the windows view or your glazing. So once you have geometry that's been filtered in these cove tool views, you are then ready to export all of this geometry on our platform. And if you do need to make any changes, you can simply do that by hiding these objects. For example, in this particular case, we have these overhangs, which are essentially not, floor slabs, and we can actually benefit out of having them hidden in this view since they are not regularly occupied floor slabs. So all you would need to do in this case is select them and hide them in this view. So once you have followed these steps in all the views, you can then go back into the plugin and click on Export All. And once you have exported all of the geometry from these 11 views, you can then visualize the building on our platform. So for this particular example, I did have it export earlier. So this is the building that was exported from Revit. And as you can see, we also preload context from OpenStreetMap around the project location you give us. So this is that U-shaped building that was exported earlier with all the simulations completed. And our simulation timeframe for exporting from the modeling platform onto our platform is anywhere between 3 and 15 minutes. You really should not be waiting longer than 15 minutes since we are a web-based platform. All of these are run on our servers to give you faster results. So that's on the Revit export. Let's now jump into SketchUp. So for a SketchUp model, there are a few things you want to make sure. First thing is to have single surfaces only. So your model should only have single surfaces throughout all the categories. So in this particular example, all the surfaces in my or in this particular model are single plane only. And before we continue with the process, we also want to make sure we don't have any grouped objects as well. And to help in that cleanup process, if you do have grouped objects, you can use this explode button right here. So this is the Cove tool interface for the SketchUp plugin. It does have 2 additional buttons to help you clean up that model. So this first button over here is the explode button, and that would help you if you do have a model with thickness or if you have grouped objects, it is going to explode it. So now we have single surfaces only for the entire model. So again, the first step would be to update your login, which I already did earlier. Second step would be to select the project. So let me look for that project again. And that is the project I want to export to, and I'm going to click on Submit. Once we have that project selected, we would then go into step 3, which is to make sure everything in the model is part of the untagged layer. So the plugin looks for geometry that is exploded and single surfaces only and all placed in the untagged layer. And again, to make sure that your geometry is present in the untagged layer, we have another button right here, which says move to untagged. So that's going to ensure that your geometry is all visible in this untagged view. So now that we have everything in untagged, we can go into step 4, which is to create Cove tool layers, just like how we created it in Revit. So essentially, it's going to be called tags over here. And again, we have the same 11 categories. And there are, again, certain rules set up based on how SketchUp is built. There's not a lot of information to grab onto, especially when we're creating these Cove tool layers, but we are still able to identify, for example, what's an exterior wall versus an interior wall. For example, right here, these are all your interior walls, the exterior walls, all your roof slabs, and floors within the project. And again, it would be a quick and easy step to make sure your geometry is in the right tag. And in case of SketchUp, all you have to do is, if you do need to switch out a particular object type to a different tag, you would select it, go into the entity info and switch out the tag assigned to it. So those are the quick and easy, simple steps. And we are also, of course, able to identify glazing based on translucent material that has been applied to the object. And of course, any other parameter, for example, any horizontal objects that are outside the envelope will be assigned to the Cove tool shading device view. So these are certain rules that we've applied to the plugin to help classify your geometry and, of course, limit that cleanup process. And once you have accurately placed or correctly placed all your objects in the right views, we can then click on this export button to send geometry onto the platform. And I'm also, again, going to show you this exact model on our platform. Okay, opened up the wrong one. So yeah, right here, this is the model that I exported from SketchUp. And like I said earlier, we do need single surfaces since SketchUp is not, a BIM tool. There is thickness involved if you have modeled it with thickness, but based on the rules that we can grab onto, we do need single surfaces for this export. Yeah, so now let's take a look at Rhino. So in Rhino and Grasshopper, of course, so essentially it's a Grasshopper script that we have developed in order to, again, export your geometry to our platform. And like how I mentioned it for SketchUp, for Rhino as well, we do need your geometry to be single surfaces only. So again, in this entire model, these are single plane geometries for everything that has been modeled. So you have your windows, exterior walls, your roof, and any other object in this particular model. And let's just take a look at the script real quick. It is definitely an intuitive process. We've simplified the script in order to limit the amount of steps you are following. It would essentially start with giving us your, by you giving us the username. So I'm going to do that real quick. Since I did log out, there is a timeout for the login. So you do need to log in again. And let's put in the password. Great. So once you have logged in, you will then give us the project URL, which you will find on that particular project that you have created. So when you do create a project, we need this URL on top in order to connect to this particular project from the Grasshopper script. So once you give us that project URL, pretty much you will get connected to the project, and all you need to do now is connect BREPs from your model onto different components on this particular script. So I'm just going to give it a minute to open up. Yeah, we're ready. So essentially, once you give us the project URL right here, it is going to give you feedback on whether it was connected or not. So we have this project that was connected successfully. It was a single use, so it already selected all of that. We're reducing the amount of information you need to give us. And the next step would be to give us these these object surfaces. So that's what we're going to connect here. So back in the Rhino model, it would be definitely easier if you have all of your layers set up. So here, for example, let me just reduce this real quick and show you all the different categories that were developed. So here you have all your exterior walls. So essentially here, you're going to select these BREPs and then assign it to these components. So right now, what I have selected are all of the exterior walls. So all you would do is select those BREPs, go into the Grasshopper script, and then right click on that component and set multiple BREPs. And you're going to follow that for the remaining categories. And once you connect all the BREPs, that is the only step you're going to do, and the project is automatically going to compute the results. And once you have completed connecting all the BREPs, you can go back into the Cove tool project and find that geometry exported. So essentially, this is that model that I exported just a few minutes ago with all the simulations. So yeah, that is the Rhino export. I did want to also point out that we are working with a new version that's coming out very soon, and you are now able to send daylight meshes back to Rhino, and you can visualize it level by level and get a breakdown of SDA and ASC, and also receive a triangle count error reporting. So this is definitely something I wanted to mention for the Rhino plugin because it is going through a huge update in the next few hours. So yeah, that's actually the end of the plugin demonstration. And I can give it back to Patricia to just go ahead with the final slide.
Okay, yeah, so this is our final slide. Thank you everyone for attending this webinar. We're happy to answer any questions. We have about 10 minutes left in our allocated time slot for any questions that you may have. I saw that there was one that Patrick had addressed in the chat regarding the messy models. Maybe we can take a look at this one, Udiksha, and then try to provide a little more insight if needed. So the question is messy models. There's always a conflict between the presentation and the LOD requirements of a project and the simplified abstraction of geometry that's required for energy models. How do you think we can reconcile the need for a single source of truth for when contrasted against the different modeling requirements for analysis, presentation, and coordination, especially at the late stages of a project's life cycle, given the context of ASHRAE 209 and late-stage analysis for value engineering, change orders, and occupancy? What Patrick wrote, which I totally agree with, one approach which Udiksha is highlighting in the views is to ignore the high LOD items when importing into an analysis model. For example, high LOD items like banisters, railings, and of course MEP elements can all be hidden and ignored in the analysis model. Do you want to add to that, Udiksha?
Oh yeah, sure. Of course, maintaining that single source of truth, like you are saying, we don't want you to remodel exactly where you actually lose out on data. That's when you are not keeping that information together. So of course, that's why we work with ways to be able to not necessarily remove objects, but simplify and keep a representation of what needs to be exported. And when it comes to presentation, yes, it is going to get super detailed, which is why when you are in your early design stages, you are able to, keep the necessary amount of information that is going to represent your building overall. But definitely limiting the amount of data that's going into simulation platforms is the way, and any other detailed objects, that Patrick mentioned, is what's the right approach, not necessarily remodeling to limit that data.
Yep, absolutely. Are there any other questions that anyone may have that we can address?
Yes, one question regarding HVAC, whether that's something that's planned in the future for potential translation from BIM to BEM.
Sure. Yeah. So, Udiksha, did you want to answer that, or do you want me to answer that?
Can you elaborate on the HVAC side of things? Is that from BIM or like that is a different analysis?
Yes, it's for example from BIM, definitely BIM to BEM, related to, because you showed mostly, I think, geometry aspects,
Mm-hmm.
whether there are efforts existing or in the future for translating other parts. HVAC is obviously an important one. And if that's something that you've already done work on or planning to in the future.
Okay. Yeah. So for HVAC and mechanical specifically, I know that on the cove.tool side of things, we're not working on being able to import the equipment geometry, but we are taking in mechanical data that is needed to be able to run that simulation. So that process, we also have a load modeling to which Patrick Pease can actually speak a little more on if he's inclined. But we do have that aspect of it where you are able to model within our tool itself. So Patrick, did you want to add to that?
Yeah, definitely. I can kind of continue that discussion. I think when it comes to HVAC, what we're trying to do with these models, we're hoping to be doing this analysis before anything's been drawn for HVAC. No ductwork should be drawn before we run some analysis. So when it comes to data flow, it's more so kind of taking the architectural, that level of BIM into our energy and our load model. And that's actually the other direction that we're trying to work towards, of taking what should the design be, push that into the BIM from the BEM. So that's one of the aspects that we're kind of working with a cove.tool, kind of doing that load modeling with the platform and pushing the data back so you can create all of that.
Yeah.
Okay.
And then
there's another question. Yeah, go ahead, Patricia.
Yeah, I was going to refer to the comment here that is in the chat, that there's an argument that the topology of the MEP elements and system wants to be included in the energy model. This person recognizes that the scope of the question and the cove.tool suite is targeted more at the early stages rather than the late. Something that typically comes up is the desynchronization of detailed MEP analysis element late in the project's life cycle. So, I mean, yeah, I think, as Patrick mentioned, that typically I know that in my past life, whenever I would work on projects, we never really saw very much MEP geometry in the models itself. And it's for good reason. Typically, those decisions are not made until a little bit later on. But what we want to do is to be able to push at least some of the informational parts to the early stages so that we can simulate how that will impact the performance if we plug in one system versus another. And I think that later on, detailed MEP analysis is always definitely beneficial. But as Patrick mentioned, that a lot of the equipment and the ductwork that is modeled can be typically very heavy, and if we can actually make a lot of the decisions that we need to make based on just information and not necessarily relying on just the geometry. So that is sort of kind of I would say like a middle ground compromise between the two, particularly in the early stage of analysis.
Yeah, I'll just come off mute for a quick second here. Just not to be like super annoying, but it's just, I think it's always useful to think about kind of like the full life cycle of where we're using an energy analysis, and like, sure, the literal geometry isn't included in your energy model, but the systems representation, right, that topology is always going to be there. And I think something that's always useful, as far as, especially if from the MEP side of things, certainly being able to extract, a good clean like geometry, right, that defines our envelope. But if we're going through the effort of creating systems within our authoring tool, right? We want, there's always, I think there's always a desire to be able to include that information in the analytical representation. And you really get an interesting problem as the model evolves throughout its life cycle, especially if you want to try and bring in some of these later stage or more detailed sort of modeling cycles. How do we conserve the information that comes from our systems and how it interfaces with the different physical, the geometric elements of our buildings? How do we recapture that from the single source of truth, so that if the owner wants to do a occupancy model, or if we want to do a value engineering analysis to look at changing material properties or something, how do we reclaim that effort, right? Because conceptually, you should have already you should already have your systems modeled at that point, right? But we just want to change this element or that element. But if we're always looking at it, if we're always looking at the construction of your energy model from the geometry aspect only, there's always going to be a huge amount of work that goes back into rezoning and reconfiguring your systems and your controls. So I recognize, like I said, it's not really within the scope of what cove.tool is kind of doing, but it's something that I think is fun to talk about, and figured I'd bring it up.
Yeah, thanks for bringing up those points, Matt. Definitely, there is interest in the industry for that translation also of the HVAC and part. But as the team mentioned here, the in the early stages, when you have only the geometry, it's also useful to focus on that as well and move on potentially to another tool like OpenStudio or Energy Plus to do more equipment and HVAC analysis. But in the future, adding that capability for HVAC translation is something that will definitely be useful to the industry as well. Another question in the chat there related to the geometry, the last question there, whether there is a capability to bring in thermal properties of the envelope, part of the BIM to BIM translation at this point, like U values or different properties like solar heat gain coefficient and so on.
Yeah, so currently there is not, but, and again, keeping in mind that we're sort of in the early stage side of things, right? So we're typically not seeing this information come through anyway. So something that we do have coming out fairly soon is actually an assembly feature. So this is the point where you can bring in your geometry, your early stage geometry, and then you can begin to assign assemblies from our tool, which has all of these performance values that are already integrated into that assembly data, so that you can then run those simulations with the appropriate performance value. On top of that, we're also including embodied carbon values on all of the products that we'll be using to build those assemblies, as well as unit cost. So this way, the values that we're working with on the cove.tool side is going to be a little more detailed, I would say, and it's going to match up with the energy code that you are selecting for your project.
Excellent. I think that especially the carbon part of it is really interesting, something new for sure. Another, we'll probably take one last question there in the chat. Maybe one of you could address it. I think it deals with energy code assumptions there.
So how does your software take into account heating loads from, say, occupancy, electrical equipment? If all of this information comes from ASHRAE or other codes, is this a feature that allows you to customize some of that data? You are right on that assumption. We do follow ASHRAE manuals, ASHRAE user manuals, ventilation inputs, and energy code requirements for all the inputs to pre-populate all of these categories like occupancy and electrical equipment, so on. And you are able to edit them. And the reason we provide that is because you would, of course, want to meet different targets for your project. So you are able to edit them, but they are pre-filled for you based on these assumptions of energy codes, ASHRAE manuals, so on.
Okay, excellent. Well, that brings us to the end of this webinar, and I want to thank Patricia and Udiksha and Patrick from cove.tool for a very interesting presentation on their workflow BIM to BEM. And thanks everyone for attending live. And if you're watching this after the recording, then enjoy the recording as well. Thanks everyone.
All right. Thank you for
Thank you so
having us.
much. Thank you.
Thank you.
Us.